Okay, so those kind of thing already we have discussed in the last class. Okay, and all those related terminologies of bell rate, and what do you understand by like open as well as cross belting. So those things we have discussed, and later on we have discussed about like all those cone pulley and all. Okay, so the theory part basically is over. So I told you to like write down, note down that particular. Sorry, I think this time the recording has started, na?
Yes, sir.
Yes, sir.
Okay, okay. So I told you to like write down all those terminology. Okay, terminology means the expressions. Sorry, not the terminologies. Okay, so today we are going to solve some problem related to that. So all of you can take out your copy and pen. Okay, so that you can try alongside me. So in the meantime, I'll be revisiting the expressions. Okay, which will be using while solving the different problems. So is the screen visible?
Yes, sir.
Okay. Okay, so we have seen that basically the effect of sleep in velocity ratio is to decrease the velocity ratio. There we have seen basically your velocity ratio is given by considering the sleep can be given by this expression where this S is the total percentage sleep. So we consider sleep as a percentage sleep only, okay, and this S value is this. So similarly about creep also we have discussed, and we have discussed about the length of bell. So there we have seen that to find out the required length of bell for open belting, this is the expression L equal to pi whole into R1 plus R2 plus 2x plus R1 minus R2 whole square divided by x. So this x is nothing but the central distance between the two sub driver and the driven sub. Okay, and R1 R2 they are the radii of the bigger and the smaller pulleys respectively. Okay, so in the case of your open belting, so angle of rep is 180 minus 2 alpha. In case of cross belting, the angle of rep is theta equal to 180 degree plus 2 alpha. And the expression for finding out the length of bell, it is somewhat similar, but this R1 minus R2 gets replaced by this R1 plus R2 whole square. Okay, so this is the sense here. Rest is similar. Next, the power transmitted by filter we have seen. This is the T1 minus T2. That is the basically the driving tension. Okay, and driving tension into the your linear velocity of that particular belt in meter per second. That gives you T into V. Basically gives you the power transmitted by the okay, where T1 and T2 are the tension in a tight and slack side of the belt in Newton. Similarly, we have seen one very important relationship, that is the ratio between the tension, okay, for flat bell as well as for free bell. So T1 by T2 it is given by e to the power mu theta. So this theta you have to be careful. You have to consider that a radian. Okay, that is for flat bell, and for free bell it is T1 by T2 equal to e to the power mu theta divided by sine of that alpha. So that alpha, okay, that 2 alpha was the groove angle in the groove angle where the V belt has been placed onto that particular groove. Okay, so in place of your flat belt, that particular groove angle, as there is actually no angle, so that becomes, or alpha becomes kind of 180 degree, kind of flat. Okay, so half of 2 alpha becomes 180 degree, not alpha. Sorry. So from there, alpha is kind of 90 degree. So ultimately, sine 90 degree, okay, is 1. So it becomes e to the power mu theta only. Okay. So next, while considering the centrifugal tension, we have seen that centrifugal tension is given by mv square, where you have to be careful with this m. Okay, this is the mass of the bell per unit length of the bell. So this is not only in kg, so it will be in kg per meter. So per unit length, what is the mass of the bell that we consider, and this v is linear velocity of the bell, and the maximum tension allowable that we have seen that is nothing but the P1, that is the tension in the tight side. So tight side tension is definitely more compared to your tension in the slack side. Plus, if you consider the centrifugal tension, that has to be added. So that becomes the maximum tension to which the we can subject the belts can be subjected. Okay. Similarly, for maximum power transmission, we have seen this is the Tc has to be one third of T. Okay, so that centrifugal tension is one third of T, and V becomes root over 3 by 3. So these are the necessary equations which will be repeatedly using for that. And apart from that, you can go through about some, code pulleys and step pulleys. Okay, where in the same shaft, driving shaft or driven shaft, basically pulleys of different diameters are actually mounted, and so by engaging like this not engaging, so by pressing the belt of our was a particular set of pulley, so we can get different speed, okay, speed ratio. So generally in the late for getting different speeds of for different operation like for trading, turning, etc., we there's a cone pulley is used. So in the small press, okay, there is multiple velocity ratio, obtaining multiple velocity ratio that is possible there. Okay, and apart from the normal configuration, you can have we can have idle pulley or jockey pulley, okay, which can also be just like in the case of idle gear. So idle pulley also can be given, okay, sometimes, or idle sometimes also called jockey pulley, which increases the tension in the bell when it is loose. So that is good. Similarly, fast and loose pulley drive is there, intermediate pulleys are there, so you can just go through it, or maybe you can go through it, no problem. So now it's all we're going to solve this problem. Okay, I hope that's clear up to this one. You're ready with pen paper?
Yes, sir.
Okay. So we are going to solve the numerical. So it states that a prime mover which is running at 300 rpm, it drives a DC generator at 500 rpm by a belt drive. Okay. So diameter of the pulley on the output shaft of the prime mover is given as 600 mm. That is the diameter of pulley at the output shaft. And considering a slip of 3%, you need to find the diameter of the generator pulley if the thickness of the belt is 6 mm. So once these are given, so find out, write down the given data. So it is given speed of the prime mover, that is N1 equal to 300 rpm. So speed of the output DC generator, okay, that is nothing but N2. So this is 500 rpm given. So N1 N2 is given. So diameter of the pulley on the outer surface of the prime mover, that is D1, okay, or because prime mover speed we have considered N1, so D1 is 600 rpm given, and slip is given, percentage slip is 3%. Thickness of the belt T is given 6 mm. Let's consider D2 be the diameter of the generator required one. Okay. So now from your normal expression for velocity ratio, considering the belt thickness as well as slip, so what we can write N2 by N1 equal to D1 plus T divided by D2 plus T whole into 1 minus S by 100. This 1 minus S by 100 comes because there is slip in that particular system. So percentage slip that is given is 3%. Okay. So after that, rest is simple. So other things are given. N2, N1, that is value is given. D1 value is given. Thickness of the belt T is given, and percentage slip, that is 3% is given. So just by putting those given values, okay, only unknown is D2. So we can solve for D2. And after solving, so D2 we have obtained as 346.69. So these are straightforward problems. Just if you know this relationship, you'll be able to find out. Similarly, some straightforward problems like finding out the required bell length for suppose open bell drive or cross bell drive, those are also sometimes asked. Okay, so there directly will be whatever the given data, suppose radii of the pulley, similarly the central distance, etc. Those things, if it is given, so directly you'll be able to find out the required length of the particular belting for the open belt, or maybe it may be cross belt. Okay, so this is a simple one. Okay. So similarly, if sometimes you may be asked about the initial tension that is there in the belt. Okay. So actually, what happens? A belt which is fitted on the pulley is basically it has got some tension, because of which only it can run continuously over the pulley. If there is no tension, if it is not under tension, it will automatically fall off that particular pulley. It will not, like, all those friction drive will not work. Okay. And this initial tension which is initially there is known as the initial tension. Okay. T naught. So, let's consider T1 be the tension in the right side, just like in the previous case, T2 be the tension in the slack side. Okay. So from there, we can keep on deriving it, and ultimately what we get. Okay. So if you consider the centrifugal tension, then the initial tension requirement is T1 plus T2, that is the tension in the test side, plus tension in the slack side, plus twice of the tension, centrifugal tension divided by 2. Okay. So this TC is centrifugal tension, that also we have considered. Okay. And similarly, there is very uh, important relationship which is very much required while designing the belt. Okay, belt designing, even in machine design also you'll be requiring that. Okay, so this is basically this expression is which is required is, let's consider sigma t be the tensile stress which is there in the bell in newton per meter square. Okay, and small t is the thickness of the bell in meter. B be the, let's consider the width of the bell in meter, and T is the maximum tension to which we can subject the bell. Okay, so in that particular case, this is very important relationship. So the maximum tension to which the bell can be subjected to, that is T equal to sigma T B T. Okay, so this is like B into T gives you the area. Okay, so stress all of you already know, right? What do you understand? Stress means in normal case, how can we get it?
Force per unit area, sir.
Yes, correct. Okay, F by A. Okay. So now in the case of your well pipe, okay, if T is the thickness, B is the width, ultimately T B into T gives you this area. So area is nothing but this. Sorry, I lost network connection in college. Okay, now it is being re-established. So all of you can hear me, right?
The slide is not visible, sir.
Yeah, slide I am going to present. Okay, but you can hear me, right? Okay, I'm going to
Yes, yes,
uh,
yes,
pre- I'm going to present the slide. Okay, so now I think it's visible.
yes, sir.
Yes, it is visible, right?
Yes, sir.
Okay, so we are there. We are talking about that stress. Okay, stress is basically this force per unit area. Okay, so that is F by A that we can write. And in the case of belt, right, if the thickness of the belt is suppose T and width of belt is your suppose B. Okay, so that cross sectional area it becomes B into T. Okay, that means I can write in place of A B T. So F, okay, which is nothing but here in our case, this is the that we are talking about the tension. Tension also is a kind of force. Okay, so T becomes sigma B T. Okay, so this is what is being written here. Okay, so now if we also consider the centrifugal tension, then we know the maximum tension to which we can subject it to is the tension in the tight side plus the centrifugal tension. Okay, that means T is replaced by T1 plus Tc, and rest is similar sigma Bt. Okay, if centrifugal tension in the question they ask you to consider say, centrifugal tension, then this will be the case. Otherwise, this is the direct. Okay, and this is very much important relationship for designing of build. Apart from that, that ratio between the driving tension, okay, that T1 by T2 equal to E to the power mu theta, that is also one of the very important relationship which will be which while solving the problem will be each and every time you will be recurring. And there you just remember, so that mu is nothing but most of the times it will be given in degree, or you'll be able to find out from the geometry in the theta in terms of degree only, but you need to replace it with, or you have to convert it to your radian. Okay, is that correct? Okay, so and you need to find out the diameter of the driven pulley considering two cases. One situation is bell thickness is 5 millimeter and the total slip is 4%. In the second case, same bell thickness is 5 millimeter, but we are considering the slip to be 2% on each pulley. In the previous case, it is total is 4%. Here, 2% of each pulley. So we are going to see is there any difference in that particular case, whether it's going to be 2% plus 2% directly 4%, or will there be any change? Okay. So for that first case, we are you write down all those given data. That is n1 and 2, all those things are given. Diameter is also d1 is also given. S is given. For one case, this is the total case. Okay. Another case, it is the s1 and s2 that is given. Okay. So now what we know? We know n2 by n1 we can write as the d1 plus d divided by d2 plus d whole into 1 minus s by 100. So 1 minus s by 100 is nothing but if you just do it, 1 minus s by 100 itself is 100, 100 minus s divided by 100. Same thing. Okay. So now by putting n1 and n2 value and d1 value and the thickness value and the first case total percentage slip is given as 4%. So directly this s value becomes 4. Okay. So in this first case, we are going to directly obtain d2 after simplifying. Just use the formula and simplify. The next case, let's see what happens. Next case, it is given s1 is like 2% and s2 equal to 2%. Okay, s1 is given 2%. That is on each pulley it is given, no, 2% on each pulley. That means s1 2%, s2 2%, and we know total percentage slip is given by s equal to, it is not just the addition of s1 plus s2, but it is s1 plus s2 minus of 0.01 s1 s2. Okay, so in that case s value you have to replace by total percentage series. If individually you have to consider, that is s1 plus s2 minus 0.01 s1 s2. Okay, so 2 plus 2 minus 0.01, so there will be slight change here. So it becomes s value becomes 3.96. By putting 3.96 as the s value, now we have obtained d to be 304.9. Right now this is very minor sense. Okay, but if that becomes sometimes very prominent whenever we are talking about like some different values of your slips, okay, on both the values. Okay, but it actually gives you an idea. That means it is not just the single direct summation of the slip in both the cases. Okay, clear? Is that clear?
Yes, sir.
Yes, sir.
Okay. So now we are coming to one actual type of problem related to like build rate design. Okay, that means what kind of build will be required for a particular task. Okay, so these are kind of actual kind of problems that you need to be focused on. Okay, so it is saying that the following that are related to a flat build rate. So these things are important. This is for flat build. Okay, so power transmitted is given as 18 kilowatt, diameter of the pulley 180 centimeter, angle of contact 175 degree, speed of the pulley, okay, so 300 rpm, coefficient of friction between belt and pulley 0.3, permissible stress, that is sigma t for belt is this much 300 newton per centimeter square, thickness of the belt 8 millimeter, and the density of the belt meter is given as 0.95 into 10 to the minus 3 gram per centimeter. You need to find out the width of the belt required and by considering centrifugal tension. So now first whatever is given, all those given that I will write down. So power transmitted P equal to 18 kilowatt. So 18 into 10 to the 3 watt. Diameter D 180 centimeter, which in terms of meter becomes 1.8 meter. Theta, that is the angle of contact, theta is given 175 degree. Okay, n is given 300 rpm, mu is given zero point 0.3, and this permissible stress, that is sigma 300 newton per centimeter square in SI units. So 300 into 10 to the 4 newton per meter square. Okay, so thickness given 8 mm, that is 8.10 minus 3 meter, and the rho is given, density for the wheel material, and that in terms of SI it will be 0.95 kg per meter cube. You need to find out weight of the bell, that is B. Okay. Now from our bell design criteria, what we already know, we know the maximum tension to which the bell can be subjected to is given by T equal to sigma A, that is sigma BT. Just now we have considered now. So this sigma is given. Okay. So 300 into 10 to the power 4 is the sigma value. B we don't know. Okay, B will remain as B, and thickness is given. Okay, so thickness is given. So after solving, it is 24 into 10 to the power 3 into B. B remains. Okay, and this tension means it is a kind of force, so unit will be Newton only. Similarly, the peripheral velocity, that linear velocity of the bell, also you will be able to find out, that is V equal to pi dn by 60. So by solving, so the things are already given. Pi is pi, d is already given as 1.8 meter, and the RPM is given as 300 RPM. P value is 60 gives you V equal to 28.27 meter per second. Okay. Next thing, if you need to follow here it is said, so you need to consider centrifugal tension. That means the centrifugal tension value also will be required, which is given by T is equal to mv square, if you recall. So there the v m was the v just now we have obtained, because mv square will be required. Okay, v is obtained, m is required, and that m was, if you recall, it was the mass of bell per unit length of the bell. Okay, so kg per meter. In that consideration, that way we need it. Okay, because that is not the only mass, but it's mass per unit length. So how can find out? We'll be able to find out the mass of bell per unit length. So that m equal to, so rho is given. Okay, so we can write m equal to rho into a. A is nothing but b into t. Okay, so just by putting the values, rho is given. Okay, b remains as b, thickness is given. So m becomes 7.6 into 10 to the minus 3 into b. So this is in kg meter. Okay, that is what is required. So once I have m, once I have p, so centrifugal tension Tc will be able to find out mv square. Just put the value. Okay, and tension once again, this is a the, if by putting and simplifying, so this value is obtained as 66073.8 into 10 to the minus 3 times the b. Okay, so b will remain. Till now b is not known, ultimately we need to find out b, and this is centrifugal tension is a force only, so Newton. Okay, now we know that maximum tension, if we consider the centrifugal tension, is given by T equal to T1 plus Tc, where T1 is nothing but the tension in the tight side, Tc is the centrifugal tension. So from there we'll be able to write down tension on tight side, that is T1 equal to T minus Tc. So T just now, we already have the maximum tension is given, okay, to which it can be subjected to. So T, I think somewhere it is given. Let's see. Yes, so we have maximum tension we have found out here. T, okay. So and T1, the TC just now we have obtained. So T1, that is the maximum value in the tight side value. Okay, we'll be able to find out. So after simplifying, we have obtained T1 to be this value in terms of B, and unit will be Newton. Write down Newton here. Okay, so this will be Newton only. Up to this much, is it okay? All of you are following me?
Yes, sir.
Okay. So now we know TC, we know T1, but we still don't know T2. And that T2, if we need to find out, it is said that for power transmitted, that is value is given, and power transmission we know that is given by P equal to T1 minus T2 into V. So V is already there, we have found out. So T1 we have found out. What is required? T2. Okay, so T2 is not given, but we have got a relationship to find out that, okay, which is in terms of the ratio of the tension of the tight side versus the slack side. Okay, that ratio in case of flat bell, this is for flat bell we are talking about, is given by T1 by T2 equal to e to the power of mu theta. This is very important, this relationship. Okay, so now T1 we just have. Okay, T2 we don't know. E is a standard value. Okay, E is known. Mu is given as 0.3, and theta is given in degree as 75 degree. So into we have to multiply pi by 180, which will convert it to radian. Okay, so e to the power mu theta, will just put that value, and by simplifying e to the power mu theta, it gives us a value of 2.5. Okay, so after that, like T2 is unknown, so T1 is known, so T2 becomes 95,9597.57 times the B, and this is in Newton. Okay, so write down the unit will be Newton. Okay, T2 in Newton, T1 also in Newton. So now this T1 and T2, which is known now, okay, and P is already known. So what we can do, we can correlate that with the power transmission value. So power transmission, required power transmission, that is already given as 18 kilowatt. Okay, P is given. So what we can use this expression P equal to T1 minus T2 into V. Okay, so power transmission is given 18 kilowatt. So 18 is equal to 3. So T1 and T2 that now we have found out, which we are going to use here, T1, T2. Okay, but in the case of T1 and T2, if you see properly, so here T1 is some numerical value multiplied by the B that remains. Similarly, in T1, it is also in terms of the breadth of the belt. Okay, that is still unknown. Other things are known. So here we can take B common and the values will numerical values will come. Okay, the coefficients will come. So other things are everything in this expression is known. It is remaining only in terms of B. So from this expression we'll be able to solve for B. Okay. So B is obtained as 0.044 meter. Okay, that is the breadth of the. Okay. So now this value, that means this is the required breadth of that particular bell, so as to sustain this particular condition. Okay. So this kind of problem, that is the designing of bell, that is also important. So solve this kind of problem. Okay, design of bell or bell design. So here what are important? So definitely given that you'll definitely find out. Okay. So apart from that, so mostly the important relationship which you need to know is bell design of bell. So that is basically equal to sigma bt. This is one of the important one. Velocity of bell pi d and 60. Okay, then the centrifugal tension relationship, that is mv square. Be very careful, this m is not just the mass but mass per unit length. Okay, so similarly maximum tension, that is should be known, T equal to T1 plus Tc. From there, sometimes if you require T1, then also you'll be able to find out. Sometimes if you require to find out Tc, that also might be found out if others are given. Okay, similarly for flat bell, this T1 by T2 equal to E2 by mu theta, very important relationship, and the relationship regarding the power transmission is important. Okay, so this thing if you know, you'll be able to solve this problem. Clear? Is that clear? Seems like you people are sleeping. Some of you are just have
No,
just
no,
joined.
sir. Not sleeping, sir. Not sleeping. Listening to you.
What about others? Others are sleeping. Artisman.
Yes, sir.
So, is there any confusion?
No, sir.
This is not.
Yes, sir.
Yes, sir means what is the confusion? You have understood this question. Listen, how to solve it. You have just joined and there is no input, na? Kosumatari,
Yes, sir.
understood or not?
Yes, sir. Understood, sir.
Ansari,
Yes, sir.
understood, na? Okay, I hope you have understood. Okay, so this kind of some other problems you try to solve. Okay. So now we'll move ahead to another problem. Okay, so here we need to find the length of the bell which is necessary to drive a pulley of 80 centimeter dia, which is running parallel at a particular distance of 12 meter. So this distance of 12 meter means, so this is the central distance that we're talking about. Okay, 12 meter from the driving pulley of diameter. Okay, so D1 and D2 they are given. So D1, D2 are given. So from there you'll be able to find out the radius. D1, D2 is given. R1, R2 you'll be able to find out. Okay, and central distance is given 12 meter. So as others are in centimeter, so that is up to you. If you convert to SI unit system, everything in SI unit system, or as D1 and D2 are in centimeter, if you convert these to in centimeter, then the final value will get in centimeter. So that is up to you. If you convert everything to SI unit, final answer after using the expression you will be getting in the SI unit. Okay, so now as nothing is being said, whether it's open bell drive or cross bell drive, we'll try to calculate the length for both case. Okay, we'll try to see whether there is any requirement of different sizes of length for if we go for open rail drive as well as if we go for cross belting. Okay, so first let's try for open belt drive. So we know for open belt drive, that is given by length of belt is given by pi whole into r1 plus r2 plus 2x plus r1 minus r2 whole square divided by x. Okay, this x is the central distance, r1 r2 are the diameter of the pulley, and the rest is simple. Okay, pi is pi. So just by putting the value, what after solving we have obtained the length required for open belting is 33.13 meter. Okay, now same thing we are considering cross belting, we will consider as nothing is being said. Okay, so we'll try for both the types. Okay, so for cross belting we know the solution, the expression changes here. Okay, this r1 minus r2 becomes r1 plus r2 here. Okay, r1 plus r2 whole square. So that is only the sense. And by putting the value and simplifying, we have obtained almost around 33.45 meter as the required answer. So there, if you compare both the answers, so definitely there is a there is a direct you can say. Okay, so there is difference in the length, and in general for the same situation. Okay, so for the same situation, cross belting it requires the here the length of the belt is kind of more. Okay, so in general that means cross belting the length of belt is somewhat more. Open belting the length required is somewhat less for the similar situation. This is just straightforward only. There is nothing to, if you just know the expression, there is nothing else to like understand here. Okay, just by using the expression. Next, another problem we'll try to solve, and with this problem to discuss will end. Okay, so what they're saying, so there are two pulleys. One is 450 millimeter diameter, that is suppose D1 is 450 mm, 0.45 meter. So from there, from the diameter, we'll be able to find out the radius. R1 also will be able to find it. And the other pulley is 200 millimeter in diameter. So D2 is also given. D2 is 200 mm. Okay, so from there, R1 will be able to find out. You need to find the length of the belt required and the angle of contact between the belt and each pulley. The what power can be transmitted by the belt when the larger pulley is rotating at 200 rpm? This N1 is given 200 rpm. If the maximum permissible tension in the belt is this one. Okay, maximum permissible tension is 1 into 10 to the power 3 Newton. Okay, 1 kilonewton. So T1 is given. So 1 kilonewton, and the coefficient of friction mu is given as 0.25. So what are the given things? We'll write down. So D1, D2 given. So from there we have found out R1 and R2. Central distance is given, which is given the subs are 1.95 meter apart. That means that is the x value 1.95. Okay, so N1 is also given. So the larger pulley is rotating at 200 rpm. So if the maximum permissible tension is given here, so here what we'll do for ease of calculation, we will not consider the centrifugal tension. We will just omit centrifugal tension. So in that particular case, we know T is given by actually T1 plus Tc. Okay, T is T1 plus Tc, but we are not going to T equal to T1. Don't mind this, whatever I'm writing in laptop is difficult. Okay, T1 plus Tc, but Tc we will not consider. So T1 itself is this. Okay, this value. Okay, so T1 equal to 1 kilonewton. So now, so as in the question, it is being said that there the shafts are connected by what type of the cross belting. So in this case, as they are asking to find out the length of the belt, which is just like the previous case, so we just have to use the expression for cross belting. So just now also we have just found out how to find out the length of belt required for cross belting. So using this known expression pi whole into r1 plus r2 plus 2x plus r1 plus r2 whole square by x. So here just we'll just put the value every value. Okay, and we find out L suffix c, that is length of cross belting equal to 4.975 meter. So from here we'll be able to find out like also we'll be able to find out the linear velocity of the belt. This v, this pi t1 n1 by 60. Okay, n1 is given, diameter of the bigger wheel also is given. So we'll put that value. So v value we can obtain a 4.75 meter per second. Okay, now you also need to find out the angle of contact between the belt and its wheel. That theta also needs to be found out. Okay, so determination of angle of contact between the belt and the pulley. Now, if you recall the, yes, I'll just rotate the view so that you can see one of the figure. Okay, if you recall the, wait, I'll zoom it. If you recall the figure, okay, figure of what? Figure for cross building only. Okay, okay, I think this figure is visible. Okay, so this is the cross build, right? So here this is x is the central distance, okay, r1 this is radius of this particular, okay, r2 is this one or the smaller one, okay, and this angle was 2 alpha, right? This angle was 2 alpha. So ultimately this dotted line, if you connect here, okay, this much is x only, that is the central distance, okay. So this much is up to here, up to this much, this is r1, okay, and if we extend this, okay, and from here if we project, this much is r2 radius of this, okay. So if this is parallel line, if we draw here, okay, then this angle is alpha, this angle is alpha, so this must become, this whole thing is the central distance x, this angle is alpha, okay, and this total becomes r1 plus r2, and this is the right angle triangle, right? So now if this is right angle triangle, we'll be able to apply the trigonometric relationship, okay. So we'll be so that we are going to do, this is alpha angle, okay, this is r1, this much is r2, that means the total is r1 plus r2 when this is parallel, okay. So this this hypotenuse becomes x, okay. So we are going to use the trigonometric relationship here. Understood? Clear? Is that clear? I hope so.
Yes,
No
sir.
one is saying anything. Okay. So now from there, what we can do? Okay, for cross belting, this sine alpha, that is using the trigonometric relationship, we can write r1 plus r2 divided by x. Okay, and from there, by solving alpha equal to 9.59 degree. Okay. Also for cross building, we know this angle of rapid actually given by 180 degree plus 2 of that particular alpha value. Okay. So this is equal to, this comes to be one around 200 degree, which in terms of radian, 3.476 radian. Okay. Also, you know, as this is a flat bell, we'll consider for flat bell t1 by t2 equal to e to the power mu theta. So all those values are already there. So we find out T2. So T1 is already there. That is the maximum possible tension of itself was equal to the tension in the tight side, because we have not considered the centrifugal tension. Otherwise, had it is like otherwise the maximum possible tension is the tension in the tight side plus the centrifugal tension. But this time we have not considered the centrifugal tension, so Tc becomes 0. So it is T1 plus 0. That means T1 only. Okay. So this is, we'll be able to find out T2 here. T1 is already known. So T2 is 419.37 Newton. And after that, that's this very simple. That's this, if we need to find out the power transmitted, P is already found out. Okay. T1 and T2, just now we have just found out. Okay. So just put that value in that given expression. Okay. And find out that what is the maximum power that can be transmitted. This comes out to be 2734.761. Okay. So you have understood? Have you understood?
Yes, sir.
So these kind of problems, other problems related to bell type design, okay, maybe what is the power transmitted, that kind of similar kind of other problems you try to solve, okay. First try to solve example from any book, okay. After that you go for exercise. So, so with this, this bell type related problem, okay, that particular portion is over from this module, and there is some other portion, that is the how a friction cuts work, what kind of brake, okay, lubrication, etc. Those are small parts that is there in this particular module. We'll be discussing in the next class. Okay. In the meantime, you keep on checking your Google Classroom. I have already provided some materials there. So I believe all of you have gone through it. Okay. So then we'll stop here if there is no question. Respond to your name call. Nirupal,
Sir.
Shankar,
Yes, sir.
Arshisman,
Yes, sir.
Rehan,
Yes, sir.
Partha,
Yes, sir.
Shiresh Basumatari,
Present, sir.
Hermiki,
Present, sir.
Nahasol. Hermiki, you are outside or what? You are roaming around? And not at your home or like that. So just only for the sake of joining the class, if you just join the class, you are in the bank. So in the bank, so people should be like responsible enough. Okay, in the online mode, later on you should not blame us. That means we have not understood or like that. You have to have your own like understanding because it's your life unlimited. So Nohasol, Nohasol, absent. Teja, absent. Rishikesh Nath,
Yes, sir.
and Emil.
Present, sir.
Okay. Okay. So thank you everyone.
Thank you, sir.
Thank you, sir.